Going on to topic 5.2, we're still on the chapters of polynomials, but in this chapter we're going to do multiplication in this section. Some of the words that we went over in the previous section was a monomial, where there's one term, a binomial, where there's two terms, a trinomial, where there's three terms, and these are all under polynomials. Anything more than four terms we just call a polynomial. Items 1 through 4 are matching, and these are some keywords too. Differences of squares, and then a perfect square trinomial. We may have mentioned that in the lesson, but we will be going over it today in our lesson as well. Okay, as you look at example 5, and again, part of this is strategy. What do you do? Well, there's no multiplication sign between this term and this term. There's parentheses, but that indicates multiplication. So what they're asking us to do is to multiply this monomial by this monomial. And we're just going to distribute. A negative 2 times 5 is a negative 10. X to the first times x to the second, we just add exponents. X to the third. Y to the first times y to the third, y to the fourth. And then it's always a good idea to check your answer. All right, and number 6, again, we're multiplying now a monomial by a binomial. And again, we're going to distribute. So 10t times 3t squared is 30t to the third. And then 10t times a negative 7t is a negative 70t to the second. Now in number 7, we're already moving up to multiplying a binomial by a binomial. Now a little later on in the lesson, we're going to do what is called FOIL, but we're going to do this one in the more traditional way. We'll get to FOIL shortly. Now the rule is when you have a binomial and you're multiplying it by another binomial, you take the first term of the first binomial and multiply it by the second binomial. Then you take the second term of the first binomial and multiply it by the second. Then you distribute. And you'll know an interesting thing often occurs, that in the middle there are two terms that are like terms. So you have to add these up, and you're going to get x squared minus 5x minus 36. Now, when you do the FOIL, which we'll show you later, it's actually a little easier once you get the rhythm of it, but this is the traditional way of doing it. First term, member of the binomial times the second item, first binomial by the second, distribute, add up your like terms, and you get a trinomial. And number 8 is something similar. So it's 2a times 4a minus 5, then a negative 3 times 4a minus 5. And now you're going to distribute. This will give you 8a squared minus 10a minus 12a plus 15. And again, never hurts to check your work. Yes. Again, you see there are like terms in the middle. So this will give you 8a squared. Add these two like terms up, negative 22a plus 15. And everything looks good. Again, what we're trying to show you here is the technique to do things. We're just not doing lots and lots of examples. You'll have practice, and then of course you'll have your quiz piece, and then later the test. But you want to develop a strategy for doing these. Now, we showed you the traditional way of multiplying a binomial by a binomial. Well, you could use that for a binomial by a trinomial. But I'm going to show you another way. Doing it this way is horizontally. We're going to set this up vertically, where it's x squared minus 4x plus 5. And then we're going to put this underneath it, x plus 3. Now, this method I like because it helps you to line up, as I was showing you in a previous video, like term columns, so that when you go to add them, it's much easier. So again, take the larger one, put it on top, smaller one over here. Now you're going to multiply. So 3 times 5 is 15. 3 times a negative 4x is a negative 12x. 3 times x squared is 3x squared. Notice we have it in descending powers, and there's no missing powers. So now we go to the x. X times 5 is 5x. And I'm putting it in the x column, the like term column. X times a negative 4x is a negative 4x squared. And then x times x to the second is x cubed. Now we're going to add these up, these like terms. Notice as we multiply, the variables changed, but now as we add, the variables don't change. So this is plus 15. Here we're going to get a negative 7x. Here we're going to get just a negative x squared, and then x to the third. And it's always good to check your work. And that looks good. All right, now in number 10, it's a similar example, but 3 terms times 3 terms. So again, you could do it horizontally, but it would go on sort of forever. Here, by putting it like this, you get your like term columns, and I think things work out very well. So let's just do that. And it doesn't make any difference which one you put on the top or the bottom. So I'll put y squared and again, check your work to be sure you have things right. I see I have an error right there already. Forgot to put that as a plus. That would have made a lot of difference. Okay. So negative times negative is a positive 21. A negative 3 times 5, a negative 15y. A negative times this is a negative 3y squared. Now a negative 2 times that is going to be a positive 14y. A negative 10y squared. And a negative 2y to the third. And again, check your work. Negative, 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 positive, negative, negative. I think we're good so far. All right, now, y squared times a negative 7 is a negative 7 y squared. You see, we're putting it in the like term columns. And then y squared times this is going to be a positive 5y cubed. And then finally we end up with a y to the fourth. Going to check that we're getting that in. Just about. Let me raise it up a little bit. Now, they're all in like term columns. All of the exponents are to the same power. We just have to be careful of the signs. So this will be a plus 21. This is going to be a negative y. Now, this is going to be a 10, a negative 20y squared. This is going to be a positive 3y cubed. And then this is y to the fourth. Now, once again, you could have done that horizontally and gotten all these strung out, but by doing it vertically, you're able to keep your like term columns. And as we check that, that looks good. Although I'm getting a, yeah, I think that's good there. Check my original examples, yep. Okay. Going on to 11. Again, there's no numbers in here, just variables, but they treat it the same way. Write this here, m squared plus mn plus n squared. And again, you want to set up like term columns. So this times this will give you an n cubed, a negative n cubed. This times this will give you a negative m n squared. This times this will give you a m squared n minus. So a negative m squared n. So n times each of these gives us that. Now again, we want to keep like term columns. So m times n squared is a positive m n squared. Put it under the right like term column. This times this gives me a positive m squared n. Oh, something interesting is going to happen here. And then now m times m squared gives me m cubed. I get m cubed. This cancels out, and I get n cubed. So a little later on, something we don't cover in every course, this is written as m cubed minus n cubed. This is the difference of perfect cubes. That's a perfect cube, that's a perfect cube, and a negative sign. Difference of perfect cubes. Difference of perfect cubes factor into this. And in a later section, we actually do something like that, but that's in the next course. Okay. Now for number 12, again, here we're having a binomial times a binomial times a binomial. These are just a little tedious, and what you need to do is you multiply these two, let's say, together first. So I'm going to use the FOIL that we're going to get to very shortly. So this gives me an x squared. My outers is a negative 1x, inners, so this gives me a plus x, and then a negative 2. So if you did that the traditional way, you'd have like terms, you'd have to eventually get this. And now we multiply it by this term. So this times this, negative 10, plus 5x, 5x squared, negative 2x, x squared, x cubed. Add them up, x cubed plus 6x squared plus 3x minus 10. And I can check that, and that looks good. Okay, so again, I'm using this FOIL on this that we're going to get to shortly, but once you get to do these, hopefully you've already had the FOIL and would use it as needed. In number 13, we're doing something that in our lesson we go over in some detail, and that is what we call special products. Now, a special product is sort of like a FOIL, but it's a special way of doing certain of these multiplications of polynomials. Here we have a binomial that we're squaring, and we have 3 examples of it. There's another example here we're not showing you. It's a little tedious. Again, I'm showing you the technique of the special product in which we're going to square a binomial. And you may just write it again. You could write it this way. And then FOIL it, or you could use this special technique where we take the first term and square it. Then we multiply these 2 terms together, the 2 binomials together, and we're going to get a negative 6a. Then the rule is you double it, so it becomes 12a. So just multiplying this gives us a negative 6a. Doubling it gives us a negative 12a. And then we square the last term. Negative 6 times negative 6, a positive 36. And this gives us a word we have right up here. This is called a perfect square trinomial. Whenever we multiply a binomial by itself, that is, squaring a binomial, we get a perfect square trinomial. And you might say, why is that important? Well, it's important because if you see you have a perfect square trinomial, and then later, instead of multiplying, we're going to factor this. This factors into that, because you now recognize it, if you can, as a perfect square trinomial, and that factors into that. Now, again, this is another way to write it, but the more acceptable way is to a binomial squared. So let's try it here. And I'll give you a moment to do it. I'm going to square this term, put it here, multiply these 2 terms together, double it, That's the middle term. And then square this term, and that goes there. So this is going to be 25a squared minus 40a plus 16. Now, an interesting characteristic of perfect square trinomials, the first and last term are always perfect squares. And then if you took the square root of 36 and get 6, double it, you realize you have a binomial that's squared. This one's a little more tricky because you take the square root of 25, get 5, square root of 16, get 4. 4 times 5 is 20, double it, yeah. And that's what we're doing here. All right, number 16 is a little tricky. Let me give you a moment at it. Go ahead and give it a shot on your own. Or you can pause the tape. So 2 squared is 4. X squared is x to the 4th. Y to the 10th. 2 times 7 is 14. Double it. And then square 7. And that's the answer to number 16. And this is a perfect square trinomial. Again, ours are going to be more in the easier range. They do have some in our little booklets that are a little more challenging. All right, we're continuing with this item of special products. And for our lesson right now, we want to introduce the term a conjugate. Again, put that in your notes. It's going to be a very, very important term. What is a conjugate? Well, a conjugate is something that has exactly the same terms. They're binomials that have exactly the same terms, but the signs are opposite. So we say a plus b, the conjugate of a plus b is a minus b. And the conjugate of a minus b is a plus b. These are conjugates of each other. Now another way to describe them is the product, because you're multiplying, the sum and the difference of the same terms. Okay? In fact, let's do this one as if we're going to FOIL. And we haven't officially showed you the FOIL yet, but hopefully you'll know it a little bit. We're going to multiply this term, and that gives me a squared. We're going to multiply the outers, that gives me a negative ab. We're going to multiply the inners, that gives me a positive ab. And we're going to multiply the last term, that gives me a negative b squared. Now an interesting thing happens when you multiply conjugates. That is, the middle terms are opposites of each other, so they cancel out. And you're left with a squared minus b squared, which is another term we have up here. The difference of perfect squares. This is the difference, because of the negative sign, of perfect squares. Now, what's interesting about that? Well, whenever you multiply conjugates, you get the difference of perfect squares. But later, when we go to factor, the difference of perfect squares, it factors into their conjugates. And again, these are called special products. Now, so when we multiply the sum and differences of the same terms, that is conjugates, we know there's not going to be a middle term. So all we have to do is multiply the first and last term not the outers and inners as we do in the FOIL, just the first and last. So this is going to be a squared minus 100. No middle terms. It's now the difference of perfect squares, which will factor into its conjugates. And as you look at it, here we have conjugates. So no middle term, multiply these, and it's going to be 25x squared minus 9y squared. This is the difference of perfect squares. When we multiply conjugates, that's what we get. And this bottom one, same thing. U to the 10th minus v squared w squared. No middle terms. And you'll have practice and quiz bees, and then hopefully you'll master it. As you look at number 22, and again we're still in this topic of special products, you might say, well, wait a minute. This is another way to write conjugates. Can I rewrite this? Can I put it this way? 7x squared minus xy, and this one, 7x squared plus xy. I'm just using the commutative principle that we talked about in chapter 1. Can I do that legally? And the answer is yes. So when you do this, this just becomes 49 x to the 4th minus x squared y squared, which is the difference of perfect squares, which will factor into its conjugates. Now, if you had left it the original way, you would have had this reversed. It would have been a negative x squared y squared plus 49 x to the 4th. But again, you can switch that around too. All right, this one's sort of interesting because it's using both of the techniques. Squaring a binomial, and then we have the conjugates here, but a negative sign between them. So let's just do it. So this is going to be x squared, square the first term, multiply these two terms together, double it. Now minus, I'm going to put a minus and put this in like a bracket here or something. This is just going to become x squared minus 25. But notice there's a negative sign in front. So again, from the last section, as we take this negative sign away, this becomes a negative, this becomes a positive. And notice now these cancel out. We're left with 2x plus 1 plus 25 plus 26. So this is just a little more of a challenge, and I illustrate it for you here. I looked at the other examples on the next page, and I don't believe I included them in your booklet. They get to be very tedious and challenging and more for an upper level course. So I thought I'd take a moment then, if we haven't already done it, to go over what is meant by FOIL. FOIL is an acronym where we take the first letter of each term And this will be, F is for first, O is for outers, I is for inners, and last. So first, outer, inner, last. Okay. So first terms, and now what are the first terms in a typical binomial? Well, this would be a first term, and this is the first term. So we multiply these together, and that gives us 6x squared. Then the outers would be this one and this one. We multiply those together, and we get a positive 4x. Then we do our inners, and that gives us a positive 3x. Then we do our last. This gives us a positive 2. And just as we did it the traditional way, there are like terms that come out of the inners and outers, usually. So we group those together. And that is our trinomial. Now, why is the FOIL important? Because later, they're going to ask us to factor this into its common factors. And we need to know the FOIL to sort of undo the trinomial to get it into the binomials. So what two terms did we need to get this? Well, we needed our first. To get our last term, we needed these. And then when we multiply the outers and the inners, they had to add up to our middle term here. So there's the FOIL. Again, many of you should remember it from high school, but it's an important part of what we're doing. And then this one, once again, is the squaring a binomial, where we take the first term and square it, multiply these two terms together and double it, and then square the last term. This gives you a perfect square trinomial. Then if we multiply the conjugates, we get the difference of perfect squares, which later then factor into, here they're conjugates into a binomial square. Okay, I don't know how long this was. It was challenging. Again, I'm trying to show you the techniques involved in getting answers, and now you need to practice, and good luck with it.